Introduction. So today I'd like to chat with you about a case study that we've done in the Permian Basin with our ThermoVault product. But before we get there, let's give you a little brief introduction. What is an EnviroVault? Who we are and what we do. So EnviroVault was founded in 1996. We specialize in tank components. We're trying to make the dumb iron of a tank slightly more intelligent. We do a lot of R&D and have a number of patented products that deal specifically with fluid storage in tanks. Our claim to fame is we build recessed chambers that go inside a tank, and we put things inside there, like we'll get into, that make this tank far more useful than it was before. So what is an EnviroVault? It's a recessed chamber inside of a tank. So at its simplest, it's this guy right here, and it's a curved piece of steel with a roof. It varies in size. Originally, we used this to put inside of heavy oil tanks in Western Canada, just to keep load line valves from freezing. The residual heat from the tank would keep it all free and clear. We've since evolved that concept to put in small little heaters on water tanks to keep them completely frost-free, fuel gas scrubbers, tank vapor scrubbers, and kind of the nameplate product that we're going to get into here, the ThermoVault. So this is just a photo of a early era EnviroVault. Nothing in there except for tank load lines and sample ports. And this would be on a heavy oil installation in northeast Alberta. So, the reason we're here and how I got involved with this. Incidents like this. Unfortunately, this is a stock image that we just grabbed off of Google, because all the ones that I have of things where I was involved with this happened in the middle of the winter at night, and pictures don't take so well. But this type of thing does happen when you have flamed equipment near storage oil storage tanks. So we knew that there was a need for a safe technology to replace flame-powered equipment that we were using in Western Canada for tank treating oil. These types of incidents only ever really happened on newer wells where we were employing horizontal well technology, multi-stage completions, and primarily in older areas where we were battling issues like line pressure, and the field was just not set up for what we were trying to accomplish with it. Line pressures were too high, or whatever the case may be. But there's quite a few incidents like this where tanks would catch on fire. So we knew that there was a need to do something. So one of the first trials of something that I was involved in at a production company was this guy that you see here, and it was basically just taking catalytic heaters and mounting them around the outside of the tank and trying to just recover as much of the waste heat as possible. It didn't work. Didn't work at all. So we talked to EnviroVault about starting up a pilot project, and the concept is, can we use as big of a chamber as possible and line it with the biggest heaters, the biggest catalytic heaters, which are intrinsically safe, flameless equipment to successfully tank treat light oil. So this is kind of a first concept drawing of how we're going to do this. So we've got 3 big 6-foot by 2-foot heaters inside of a 12-foot high chamber, mounted about 5 feet off the ground. So we really project that heat right into the oil-water interface. And we'll get to the reason why we set it up that way. But first things first, we did a little bit of R&D. So we partnered up with, EnviroVault partnered up with a government organization in Alberta, Alberta Integrates Technologies Futures, to design and field test a system to rival 400 barrel tank with a 250,000 BTU burner, fire tube burner in it, which is kind of commonplace equipment. So we completed a number of tests to evaluate whether or not this was feasible, whether it was going to function as we had anticipated, and if it was going to be as efficient as we would hoped. So we completed a bunch of tests. Started off with field testing catalytic heaters to ensure that we were getting the heat transfer that we wanted to. We started with the 400 barrel test tank. Initially no insulation, and then insulated it, and the same tank was also equipped with the burner equipment that we were trying to compete with, just to compare the efficiencies in the exact same scenario over time. So this is the first successful field trial. I like this photo because it shows a site where we tried just about everything and finally found something that worked. The tank in the middle, we had a fire on, and you can't tell because we replaced all the exterior coating and insulation on it, but the top half of it was pretty scorched. The tank on the left, trying to do some sort of external heat, intrinsically safe, but that wasn't working because it was not recovering enough waste heat off of the system. And then the tank on the right is the ThermoVault, and finally we got something that worked. So we found that we've been able to be relatively successful at putting these into place to effectively tank treat oil in Western Canada. We initially started putting this into 400 barrel tanks on 1, 2 to 4 well pads. We've since gone up as high as tanks that are 2,000 barrels in size, and we can get a relatively high variation of applications where this works as far as oil gravity and water pad. So this is a great photo. This is a Western Canadian installation. This is a Western Canadian installation, and there are the two tanks in the middle that are tan colored are our sales oil tanks. We didn't bother to insulate them because the oil that was coming over the top of the spillover in our ThermoVault tank was so clean that it had effectively zero BS&W. So we could let those tanks cool off to -40 and never have an issue with loading them out. This site would be about 35 API, so not worried about viscosity issues there, but it just goes to show you how effective it can be in the right application. So we were able to learn that we can use explosion-proof catalytic heat to effectively raise, maintain temperature on above ground storage tanks in the dead of winter in Western Canada. So we're able to effectively tank treat light oil. From our learnings, we developed a series of calculators that we were able to use to predict with a pretty high degree of accuracy what we would be able to do in similar instances in other areas of Western Canada. Since then, we've also been able to apply that to the Permian Basin in Texas. And we've also learned that this was more efficient than the conventional technology at the time, which was a fire tube burner and a 400 barrel tank. We were using about 28% less fuel, and what comes along with less fuel is less emissions. And the nice thing about the catalytic heaters that we're using is they effectively have zero nitrous oxide and zero carbon monoxide emissions, which is great for health and safety reasons. So this is a couple photos of our initial pilot project in the Permian. So the photo on the far left here is the ThermoVault tank being unloaded. So this one is a 500 barrel tank, 25 feet high, and then there are 4 other 500 barrel tanks, which are the 15'3" height. And on the right side of it there is the water production water tank. So here's a photo of it all said and done. This is on a single well battery, or sorry, a 2 well battery. And we were able to increase the temperature of this oil as it was coming into the tank farm about 71 degrees Fahrenheit. We were able to get it up to 111 at 400 barrels a day and 50% water. So the design of this tank was using is a gun barrel style tank using water underflow and oil overflow. It sounds strange to insulate a tank in West Texas, but we found that that was actually very effective at maintaining the extra heat that we're putting in there right into the emulsion layer. When we work backwards from our fuel input calculations, we found this to be about 86% efficient from fuel in to heat transferred into the fluid. So after a successful smaller project, we decided to try it on a big multi-well pad. So in Martin County, Texas, we were approached to design a battery for an 8-well pad with a relatively high water cut, targeting north of 3,000 barrels a day of fluid. So here's a photo of the setup. It's basically the same setup as we had before. We didn't feel the need to really change anything given what we had seen. So we're using 3 two-phase separators, another 2 vertical separators, 1 water tank, 1 ThermoVault gun barrel treating tank, 4 oil storage tanks, and the thing I want to point out, no treater. No flame-powered equipment needed at all to treat this oil. So here's a kind of diagram of how this is meant to work. So you've got your fluid coming into the top, coming down and in front of the heat area in the middle tank, which is our ThermoVault treating tank. And other than that, it's just a normal gun barrel tank. We'll pull the water off with a water leg off the bottom of it, and we will spill oil over the top into our oil storage side. So the key of how we were able to make this work is that we focus on putting the heat where it is needed the most to break the emulsion out. So if we can concentrate that heat on there, then we're not wasting any energy heating up oil that's already broken out, nor are we heating up water that doesn't have any oil entrained in it. So all the free water off the bottom slides right through without really collecting any heat at all. So we're not heating, we're parking the heaters right opposite the emulsion layer. And we're able to get to less than 0.5% PS&W to maintain pipeline spec. So in this case study, we brought on a total of 8 wells. Right along the bottom there, you can see when each well was brought on. So of note, we increased the water rate that we were seeing increased over the course of this test. The water cut was dropping as more wells were brought on and frac fluid was being recovered. And oil production steadily increased over the course of our test. So our takeaways from this, 3,330 barrels a day is the peak rates that we achieved, all the while maintaining pipeline spec oil. There's a very safe alternative to flamed equipment. I mean, these things can never really, they don't get hot enough to actually burn through steel ever. Not like what you see with flame impingement on a U-tube on a treater. And we were able to get the temperature and the heat into the areas where it was needed the most. We didn't really see a lot of change in produced water temperature. It just flowed right through the bottom. So the nice thing about this is it does all of that, and it's easy to operate. You set your heaters up, and that's it. You kind of just walk away after that. There's no real maintenance cost to this. The heaters that we employ are catalytic heaters, so as long as there's no issues with your fuel gas, it's not sour, not carrying over an excessive amount of oil, these things can last north of 20 years. You use a lot less fuel than we would otherwise use, and we can install it within a tank farm, so your footprint of your site becomes that much smaller, that much less pipe that you need to set up a battery. So what we like to do is we always like to review and evaluate any application for this, just because we want to be sure that it's going to work before we send anything out. So we have a series of data sheets and calculators that we'll use and provide just to make sure that we're confident that anything that we propose is going to meet what you need. There's a little infographic on it. So the one thing that we haven't really discussed a lot is the safety aspect of it. And the nice thing about these things is they are Class 1, Div 1, intrinsically safe heaters. We went for a shop tour of the heater manufacturer. They test them all with propane before they leave, and we watched them spray propane right on the front face of these heaters. No flare up, nothing. It just absorbs it, breaks it down into carbon dioxide and water, a little bit of extra heat, but it never gets hot enough to actually start a fire or anything like that. So it's very, very safe. These are kind of the areas where we've installed ThermoVault, so predominantly in Western Canada. We do have a few installations in primarily Martin County, Texas. But what I'd like to point out is the spread of the applications that we've been able to successfully do. We have heavy oil applications in Western Canada that are getting close to 10 API, all the way up to very light oils nearing 50. I think the highest one I have is about 48. And a full range of water content as well. Western Canadian production is typically quite dry, but it doesn't come out of the ground at pipeline spec. So we do need to do some work on it, but as we've seen, we can get it up to, we can handle any kind of water content as long as the setup is right. And across a variety of different formations as well. So in Canada, we've installed this on Cardium wells, Montney, which is primarily a gas condensate play, Dunvegan, Glauconite, Banff, Viking, Leah, Duvernay, Mannville. Duvernay is also a gas condensate play where this works quite well. And in the Permian, we're looking at, or we have installations in the Wolfberry. So what we always ask if we're gonna look at designing a site for anyone is that we get good data in advance so that we know what we're up against. So we have a series of forms that we ask for data back. So if anyone's interested, these are available on our website. Contact info is at the bottom. Just feel free to shoot us an email. We don't ever charge for a design or a consultation on this, just because we want to make sure that everyone's going to be happy with this once it gets to their site. Thank you.